Hi again. Welcome to the video on balancing chemical equations. For these, some of these are very straightforward and more simple than others. And some of these take some, you may try one way, you have to go back, erase, change it again. So sometimes they take a little bit of time to get used to, but there's a few tips that I can give you to try to help this be as smooth as possible. And then we're going to do a few practice. So first of all, we need to write an equation with the correct formulas. So here we have C3H8, that's propane and oxygen, yields CO2 and water. All right, when we balance, you will never, ever change the subscripts. All right, so our subscripts are here. Okay. The reason for this, if you change subscripts, then you change the formula completely. You're changing the identity of the compound. So if you change O2 to O3, well then now you have ozone. Okay, it's not oxygen anymore. Okay, so we're going to change coefficients, and coefficients are the numbers that are going to go out front of the formulas. Okay, we're going to go one element at a time and do this. And you can kind of keep a tally underneath each side, but the idea here is that if you have 3 carbons on the left, you must have 3 carbons on the right. So think of this as an equal sign here. Okay, because of our law of conservation of matter, okay, we cannot destroy matter. So we have to account for all of our atoms on both sides of the equations. Remember, this is our reactants and our products. Okay, first thing I would do is start with the first atom listed, and I would start with I would do all of the elements except for hydrogen and oxygen first. So balance all atoms besides hydrogen and oxygen first. Okay, there are many different chemical equations. So you may not have hydrogen and oxygen in your reaction anyways, okay, or you may not have carbon or whatever. So instead of this just saying carbon, I would go ahead and say balance all the atoms that are present, and I would start with that one just like you're reading left to right. I would start with that very first one, okay, and balance all the atoms besides hydrogen and oxygen first. All right, so we've got 3 carbons on the left. Okay, in order for us to have 3 on the right, we have to put a coefficient out front. Okay, once you balance all the atoms besides hydrogen and oxygen, and so here that's all we had was carbon because everything else is hydrogen and oxygen, then you balance hydrogens next and then oxygen. So hydrogens, then oxygens, if you have these. Okay, this helps to make for a more smooth balancing experience if you remember these rules. So balance all atoms besides hydrogen and oxygen first, then hydrogen, and then oxygen. Okay, so if we do our hydrogens, we have 8 on the left, okay, and we only had 2. Okay, so if we put a 4 here, now 4 times 2, remember you multiply the coefficient times our subscript, we have 8. So far so good. We have 3 carbons on each side, and we have 8 hydrogens on each side. All we have left is oxygen. Okay, but notice we have oxygen in both compounds. We have to be careful there. Okay, so we've got to balance the oxygens. So originally, of course, that 5 wasn't there. Okay, so let's mark it out just so so this is what we've got so far. So if I look over here, I've got 3 times 2. I've got 6 oxygens, and then I have 4 times 1. So 6 plus 4 equals 10 oxygens. So exactly what was here, I have to put a 5 in front of the oxygen. 5 times 2 gives me 10. I have 3 carbons on each side. I have 8 hydrogens. I have 10 oxygens on each side. you want to make sure that your answer is the smallest set of whole numbers that you could use. All right, so sometimes when you get to practicing these, you'll keep going on accident and end up getting double. So you'll have a 10 and a 2 there and a 6 and an 8, and you didn't realize it was balanced, so you just continued on. And so if you will just reduce that back to its smallest whole numbers, then that's technically what you should report as your final answer. All right, and so here's just a molecular view of what happened. Bonds broke and rearranged. There's propane and oxygen, and we formed new compounds. And now if you added all those up, you'd have the same number of atoms on each side. All right, we're going to practice, and I'm going to write out, so if we had C7H16 burns in oxygen to form carbon dioxide and water. Okay, so we want to balance this. We're going to start with our carbons. We have 7 on the left. We need 7 on the right. Okay, our rule is balance everything except for hydrogen and oxygen, then balance hydrogen. So we have 16 hydrogens, so we're going to need an 8 here. So 7 carbons, now we have 16 hydrogens on both sides, so 8 times 2 there. Then I need to add up my oxygen. So I have 7 times 2, I have 14, plus 8. So that gives me 22. Okay, so I have 22 oxygens. So 11 times 2 is 22. All right, so we need an 11 as a coefficient there. So our balanced equation would look like this. This next one is the most complicated of all of the ones that we do. So these are typically pretty straightforward. But I wanted to show this in case you hit this problem, and I can kind of direct you in how to fix it. Okay, you have ammonia burns in oxygen to yield NO plus water. Okay, so the examples we've done so far have worked pretty well, and we haven't had to go back and erase and change things. And so in reality, there are a lot like that, but then there's other ones that take a little bit more time. So this is one of those. So first off, if I use my rules here, I'm going to balance nitrogen. Well, I have 1 nitrogen and I already have 1 on the right. All right, so I'm just going to leave that alone. And so then I'm going to look at my hydrogens, and I see that I have 3 on the left and I have 2 on the right. Okay, so this kind of is not a problem that we can't overcome, but it's a little different than what we've seen. So there's no way, we've got to get our hydrogens to be equal, so there's no way I can add to one side and not add to the other. So a common sort of multiple here would be for us to have 6. So if I put a 2 here and a 3 here, now I have 6 hydrogens and 6 hydrogens. Okay, but when I put that 2 out in front, I changed my nitrogen to 2. All right, and see, I only had 1 here. So this is where I already went past it once and looked at it, but now I've got to go back and I've got to change it. Okay. Okay, so hydrogens we had to have 6, so we'd have the same on each side. 2, 3 times 2. And now my nitrogens are set. I have 2 and 2. Okay, now we're going to hit another issue that I want you to see. Okay, if I look at my oxygens, I have 3 times 1, so I have 3, and I have 2. I have 5 oxygens. Okay, so if I come over here, I have a subscript of a 2. So if I put a 2 there, I only get 4. Okay, if I put a 3 there, I get 6. Okay, so there's no way for me to multiply through by 2 and get 5, right? It's always going to be an even number, okay? So this is an issue. There's nothing we can put there, okay, in order to, or a whole number that we can put there, okay? So technically, if you think about it, okay, to get 5, 2.5 times 2 gives us 5, right? Okay, well, we can't put fractions in our chemical equations. Okay, 2.5 is the same as this. So if you divide 2 into 5, you get 2.5. So either one. So that's the same thing. All right, so what I do, personally, I go ahead and put that fraction in there. And then I say, okay, if I take that number and I double it, then I get the number that I want, right? I want 5. All right, so what I'm going to do is then I'm going to double everything. And when I mean everything, I mean the coefficients. Okay, so I need that number to be a 5. So if I double it, 2.5 times 2 is 5, right? Okay, so if you hit a problem where there's no way you can get an odd number, okay, then put the fraction in. That would give you the right number. Here it's 5. Okay, and then double it, because that number will then be the number that you want. But if you do that, you've got to double everything. Okay, so the 2 becomes 4. This becomes 4. And this becomes 6. So if you look at here, we've got 4 nitrogens on each side. Always check. We've got 12 hydrogens, 12 hydrogens. We've got 10 oxygens, and now I have 6, 7, 8, 9, and 10. So now I have 10 oxygens as well. Okay, so the idea behind this is just if you need an odd number, okay, you're going to have to make it become an even number. So the way to do that is to double it. All right, I hope this helps, and I will see you soon.